Hello problem solvers. So today we look at a geometry problem with a few conditions, and please have a go. The diagram looks like this. We have AB equals AC and AD equals AE, but they may not be equal. And we have an angle condition. This is not so difficult, so please try. The first impression of this problem is that somehow we need to understand this angle relation better. We are given with we have these two sides equal, so maybe we want to consider some circle, or maybe we can just drop some perpendicular and we have some isosceles triangles to work with. But somehow we need to handle this. So it turns out that if you drop perpendiculars here, you will now understand this relationship better. So let's name some angle. So let's say let's call this angle CAD, let's call it theta. Okay, and then let's call this angle alpha. Okay, then of course this is the perpendicular, and you have an isosceles triangle, so this will be alpha as well. Similarly, these two angles are the same. And why would I want to do that? Well, because I know that the sum of this angle, this one plus this one, is theta. So you see, if you consider the whole triangle, all the angles of triangle ABE, we have theta plus 2 alpha plus 2 beta, right? So that means, okay, considering the angles in triangle ABE, we have 2 theta plus 2 alpha plus 2 beta equals 180. Okay, so alpha plus theta is equal actually 90. Okay, that is the hidden relationship given to us in this relation. So so this is 90, angle FAG is 90, but these were perpendiculars, and so 90, 90, 90, so this one is also 90 degree, and we have a rectangle. Okay, so then that gives us angle FHG is also 90, and so FAGH is a rectangle. Okay, and basically up till now we have revealed some hidden information about this problem, and that's really how typical geometry problems go. Okay, initially you are given some conditions, and you need to combine this information to extract some more information in the problem, and eventually this further information will lead you to the goal. Okay, and yeah, so for typical Olympiad level geometry problems, usually you have to extract some more insights like this, like an intermediate information that is hidden, okay, that you need to find. So we are in good shape. Whenever you can extract some more information, you are probably in the right direction. Okay, let's move on. So the goal is that if M is the midpoint, then we somehow need to show that 2AM is CD, has the same length as the length CD. AM is the median of triangle ABE, and so well, we want to prove something about the length of the median, and so obviously the median formula comes to mind. Okay, if you don't know, you can look it up in the Wikipedia. Okay, there is actually, so whenever you have a triangle like this, and you have a point like this, okay, it doesn't have to be the midpoint, somewhere along, then there is something called a Stepworth theorem. I think it's Stepworth theorem, that tells you the length, that expresses the length of this in terms of the length of these. Okay, and usually I just memorize that formula, and if it is median, then I know x equals x, and then I'll reduce that formula to the median formula. And if this is a angle bisector, then you know cx equals by. Okay, and then somehow you need to simplify Stepworth theorem to get the length of the angle bisector. Anyway, that's just how I remember the formula. Okay, I just need to remember Stepworth theorem. Okay, so it says that the median formula says that for AM square is equal to the 2 of, let me give them names first. So let me call this A. Let's say this is B. Okay. So that would be 2A square plus 2B square minus BE square. Right, that's the formula for median. And well, so we want to prove 2AM is CD. That just means that we need to convert this to CD square. Right? If this is CD square, then square root both sides, we get our goal. There are two ways. The first way I tried, let me tell you the first route I tried. You know that FAGH is a rectangle, so this length is this length, and this length is this length, and CD square is just CH square plus HD square. So somehow if we can decompose these lengths, okay, BE square is BH square plus HG square. Somehow if we can decompose this length into these length, and then hopefully somehow we will get back to CD. That's the first route that I tried. It was quite complicated, and in the end I didn't really make it work. Well, it spent about 10 minutes, didn't work. And then I tried another way. So if you just think about it, is there any connection between BE and CD? Well, there is, and this is one of my favorite trick. If you consider the triangle ABE and ACD, okay, look, they both have the length AB, and BE and CD is the relationship we want. And what's good about that is that the angles are related. In triangle CAD, this angle is of course theta. And this angle, what's this angle? This angle is 180 minus theta. Okay, That means when you apply cosine law, you get the expression for BE and CD, and they are related somehow. So that's worth a try. Okay, that's worth looking into. So so you say in triangle ABE, we apply the cosine law to BE, and we get BE square is A square plus B square minus 2AB cosine angle BAE, which is 180 minus theta, right? We know that. We know this, right? So that's 90. That's alpha. So that's 180 minus theta. But actually, cosine 180 minus theta is just negative theta. This is just negative theta. I mean, cosine 180 minus theta is just negative cosine theta. So we can reduce it to plus 2AB. And then in triangle CAD, CD square is A square plus B square minus 2AB. Oops, I forgot my cosine theta here. This becomes negative cosine theta. Okay, so becomes plus 2AB cosine theta, and CD is just this. So when you add, if you just add, obviously you get B square plus CD square is 2A square 2B square. Okay, and obviously if you move this across, you get CD square is just 2A square plus 2B square minus B square. And that is 4AM square from here. And so we have proved that 2AM is CD. Yeah, the solution is quite short, but of course, before reaching the solution, I tried several things, and usually, in this channel, I like to share all the ways that I've tried. Okay, because if you just look at the solution, you can't learn. Okay, you don't know how did I come, where did I come up with that, right? But hopefully you see my trick. Okay, whenever you have triangles who have some the angle that is related, you can apply cosine law, and maybe those will cancel out, and then you will have derived some expression about the lengths, and maybe that's what you need. Okay, so so finally, let's give this a difficulty score. I would say this is at the this is like a difficult AMY exam question. So I would say this is 4 out of 9, and the character would be Neji. Oh, no space. Okay, thank you for watching.